By now, I hope you realize that replacing fossil fuels as a source of energy must be done. There are many alternatives to the use of fossil fuels, both renewable and non-renewable. Non-renewable including nuclear energy, and renewable including all of the resources I will cover in this video. Renewable energy resources are simply defined as resources that can either be replenished in our lifetimes or are perpetual. Some make use of new technology, also known as new renewables, and some make use of mature technology, aka conventional renewables. However, in either case, new research is continuously improving technologies to make these alternatives more and more viable. Conventional renewables include hydroelectric power and biomass, and new renewables include solar, wind, geothermal, and ocean water movement energy resources. First, we'll start with solar. For thousands of years, people have built and oriented their homes to make use of the sun's energy. Passive solar energy systems make direct use of sunlight to heat a building. Since the path of the sun is predictable, a building can be positioned to maximize its utilization of the sun's energy. In the northern hemisphere, for example, windows placed along the south side of the building will allow sunlight to enter year-round and heat the interior. The heat can be absorbed by the building materials, also known as thermal mass, like stone, concrete, or adobe, and in large tanks of water. In order to reduce cooling costs and avoid overheating buildings that use passive solar energy systems during the summer, overhangs can be used that block out high-angle summer sunlight while allowing low-angle winter sunlight to enter. Overall, passive solar energy conserves energy and reduces energy costs. Active solar energy systems make use of pumps to move water or a fluid like antifreeze through solar collectors, where it is then heated by the sun and then pumped throughout a building to provide heat. An active solar energy system can also store the hot fluid and allow it to slowly release its heat through non-daylight hours. These systems can also be used to heat water and replace conventional hot water heaters. A more direct approach to producing electricity from sunlight involves photovoltaic systems. Photovoltaic cells collect sunlight and convert it to electrical energy by making use of the photovoltaic effect. This effect occurs when light strikes one of the pair of metal plates in a PV cell, causing the release of electrons, which are attracted by electrostatic forces to the opposing plate. The flow of electrons from one plate to the other creates an electrical current, which is direct current. The direct current can be converted to alternating current and used for residential and commercial electrical power. Now, what are the pros and cons of using solar energy? First, the energy is free. We are not having to pay for the sun's energy. The net energy is moderate if you're using an active setup, or very high if you're using a passive setup. It's really quick to install. There are no carbon dioxide emissions, so we're not looking at a lot of global warming coming from this. There's very low air and water pollution. There's very low land disturbance because most of the time we are taking advantage of roofs or windows here. And it is a moderate cost if you're looking at a passive system. Now, the downsides: you need to have access to the sun 60% of the time in order for it to be an effective source of electricity. The sun can be blocked by trees and other structures, which is going to make it a little less reliable. Environmental costs are not included in the market price. You're going to see this as a trend throughout all of our energy sources, whether it's renewable or not. It needs a heat storage system, which is going to be one of the major downfalls here. It can be very expensive if you're looking at an active setup, and active setups need more maintenance and repair, and they tend to be a little more unattractive. In hydroelectric power or hydropower, we use the kinetic energy of moving water to turn turbines and generate electricity. We have harnessed the power of moving water for a long time. Water wheels spun by river water powered mills in past centuries. Today we harness water's kinetic energy in two major ways: with storage impoundment such as dams, and by using run-of-river approaches. Most of our hydroelectric power today comes from impounding water in reservoirs behind concrete dams that block the flow of river water and then let the water pass through the dam. As the reservoir water passes through the dam, it turns the blades of turbines, which causes a generator to generate electricity. Hydropower accounts for 16% of the world's electricity production and is currently providing large amount of energy for Canada, Brazil, Norway, Austria, and Switzerland. Now, what are the pros and cons of hydroelectric power? First, we have a moderate to high net energy yield. It's very highly efficient. Most sources say it's about 80% efficient. There's a large untapped potential. There's low-cost electricity. There's a long lifespan. Once we put these dams in place, they generally last a long time if they are properly maintained. There are no carbon dioxide emissions during operation, so we are again not looking at a high impact on global warming. It can provide flood control below the dam, so we can have multiple purposes for the dam in the first place. It can provide irrigation water, since we are pooling a lot of this river water into almost like a stagnant area. And the reservoir is useful for fishing and recreation. Just because we've dammed that water, we've made it a non-flowing source. The downsides are it is a high cost to construct the dam in the first place. There can be high environmental impacts from flooding land because of the reservoir itself. Again, the environmental costs are not going to be included in the market price. I said that's something we're going to see over and over again. We do see a slight impact with global warming with looking at methane emissions, and this is going to be because of the rapid rate of biomass decay. There is the danger of collapse if we don't have proper maintenance. It uproots people, it causes them to have to move because of the redirection of the water. It decreases fish harvest below the dam and can actually impact migrating fish, and decreases the flow of natural fertilizers to land below the dam. So again, it's going to impact those natural ecosystems. The rise and fall of ocean tides and waves involves an enormous amount of energy. The currents that flow during the constantly changing tides can be used to turn turbines and generate electricity. Currently, these technologies do not provide much energy, but they hold promise for the future, especially in coastal areas and in regions with large differentials between the high and low tides. We can also harness the heat energy being released by the surface water of the ocean as a heat source for a power plant. Here, instead of heating the water itself is already heated, and it in turn heats another chemical with a low boiling point until it generates steam and turns a turbine. So what are our pros and cons here? We'll start with the pros. It's a perpetual renewable resource, so it's something that's not going to fade away. It will constantly be occurring. The ocean is free to use. We don't have to pay for tides. They are a natural thing. There's a high net energy yield with an enormous energy potential if we realize how to harness it. It is reliable and fairly predictable. Our downsides are going to be that there are a lack of suitable sites. Not just every single coastline can have this kind of setup. There's a high cost of startup and maintenance, mainly because the salt water itself is corrosive, so you have to have special materials, and it can damage coastlines as well as the ecosystems that live there. Wind energy can be thought of as an indirect form of solar energy because it is the sun's differential heating of air masses on Earth that causes winds to blow in the first place. We can harness power from wind by using devices called wind turbines, or mechanical assemblies that convert wind's kinetic energy, or energy of motion, into electrical energy. Today's wind turbines have their historical roots in Europe, where wooden windmills were used for about 800 years to pump water, to drain wetlands and irrigate crops, and to grind grain into flour. It wasn't until 1880 in Cleveland, Ohio, that wind turbines were first built to help generate electricity. So how do they work? Well, wind blowing into a turbine turns the blades of the rotor, which rotates machinery inside a compartment called a nacelle that sits atop a tall tower. Inside the nacelle are a gearbox and a generator, as well as equipment to monitor and control the turbine's activity. Turbines can be erected singly, but they're also often erected in groups called wind parks or wind farms. Due to land and sea breezes along coastlines, there's currently a push to build wind farms along the coastlines of the United States. So what are our pros and cons here? We'll start with the pros. There's a moderate to high net energy yield. We have a high efficiency. It's moderate capital cost. There's low electricity costs, and it is falling over time as we have better technology that's also cheaper. There's a very low environmental impact. We're looking more at concerns with ecosystems than the actual land itself. There are no carbon dioxide emissions, so we're not looking at global warming concerns here. It's a very quick construction. It's not very difficult for us to set up. It is easily expanded and can be located at seas or on seas, so that we are not concerned about using up land space, and the land below turbines can be used to grow crops or to graze livestock. What are the downfalls? You have to have steady winds in order for the electricity to be generated. You have to have some kind of backup if you are not in an area with high winds. The plastic components have to be produced from oil, so we do see some kind of indirect global warming concern here. The environmental costs are not included in the market price. Again, I told you that's going to keep coming up time and time again with our downfalls. There's high land use for a wind farm because you have to have a certain amount of space between each of the wind turbines. It can't be highly concentrated into a small area. There is what is called visual pollution, where people seem to think that wind turbines are ugly and they don't want them on the landscape. There's also going to be noise pollution as well if you're near a highly populated area. And this one probably sounds a little weird, but wind turbines can kill birds and interact with migratory birds' pathways. When people use the term biomass energy these days, they mean very different things. To a poor farmer in Africa, biomass energy means cutting wood from trees or collecting livestock manure by hand and burning it to heat and cook for their family. To an industrialized farmer in Iowa, biomass energy means shipping his grain to a high-tech refinery that converts it to liquid fuel to run automobiles. Biomass consists of the organic material that makes up living things. People harness biomass energy from many types of plant matter, including wood from trees, charcoal from burned wood, and matter from agricultural crops, as well as from combustible animal waste products such as cattle manure. Fossil fuels are not considered biomass energy, even though they are considered organic, and this is because their organic matter has not been a part of living organisms for millions of years, and it has undergone considerable chemical alterations during this time. So what are our pros and cons here? Again, we'll start with our pros. We see reduced carbon monoxide, carbon dioxide, and hydrocarbon emissions. There's a moderate net energy yield for rapeseed crops and high for oil palm crops. We get better gas mileage with this, and there's potentially renewable. It just depends on how it is actually harvested in the first place, pretty much how frequently we do it. Our downfalls are going to be that we have increased nitrous oxide emissions and more smog because of the burning of these materials. We have a higher cost than regular diesel because of refinery issues. There are environmental costs, and again, they are not included in the market price. We're going to see subsidies here as well. It's a low net energy yield for soybean crops, so the amount of energy we are obtaining from these sources all depends on the crop we are using in the first place. It may compete with growing food on cropland, so it's going to increase the amount of space we have to take up land-wise in order to produce these fuels, and as a result, it can raise food prices. We're going to see a loss and degradation of biodiversity from crop plantations, and again, that's because we're looking at a higher rate of monocultures instead of polycultures. And it can make engines hard to start in cold weather because they don't have the exact same properties of the oil that we generally use in cars. Fuel cells use chemical reactions to produce electric current as it is needed. The most common fuel cells are hydrogen and oxygen as reactants and produce drinkable water as the only product. They are used in similar applications to batteries, and the reactants in the chemical reaction can be replenished as needed. For hydrogen fuel cells, the oxygen and ambient air can be used, but the hydrogen must be supplied as a gas or a liquid. Hydrogen gas is not found naturally on Earth, so we have to create it through a process called electrolysis, or the splitting of water molecules. The process of electricity generation works by stripping hydrogen atoms of their electrons, leaving hydrogen ions. The electrons flow from a negative to a positive electrode to generate an electrical current, and the hydrogen ions pass through an exchange membrane through which they combine with oxygen to create water as the waste product. So what are our pros and cons here? Again, we'll start with our pros. It can be produced from plentiful water, so it's not like we are having to obtain some obscure atom from the ground. There's a low environmental impact because our only source that we are using in the first place is going to be water itself. It's renewable if produced from renewable energy resources. So if we are taking it from water instead of another source, then it is considered to be renewable. There are no carbon dioxide emissions if it is produced from water. It can make a good substitute for oil. It's a competitive price if the environmental and social costs are included in cost comparisons. So this would be if we are looking at the cost of all of these different energy sources while including the environmental impact. It's easier to store than electricity, so storage would not be one of our big concerns here. It's safer than gasoline and natural gas. It's non-toxic and is highly efficient in certain fuel cell types. Our downsides are going to be that the hydrogen gas itself is not found in nature, so it has to be created. So that means that energy is needed to produce the fuel in the first place. As a result, we're going to have a negative net energy here. So it's going to take a lot of energy in order to produce a little. Our carbon dioxide emissions can be produced if we are forming the hydrogen gas in the first place from carbon-containing compounds. The environmental costs are again not included in the market price in most situations. It's non-renewable if generated by things other than water like fossil fuels or nuclear power. There are high costs, which eventually may come down if we have any kind of subsidies or improvements in technology. It will take about 25 to 50 years to actually phase in as a reliable source for cars. Currently, any kind of fuel cell driven cars only have a short driving range, so it's kind of like what we're seeing with electrical cars right now. There's no fuel distribution system in place because we are so heavily reliant on oil, and excessive hydrogen leaks may deplete the ozone in the atmosphere. Last, we have geothermal energy. Geothermal energy makes use of the Earth's internal temperature by tapping into high pressure, high temperature steam that exists well below the Earth's surface in some areas. This water is turned into steam by heat generated from radioactive decay in the Earth's core. The energy is used to heat buildings and water as well as generate electricity. The electricity generation itself follows the conventional power plant layout that we have seen time and time again, but the heat source itself is the interior of the Earth. So what are our pros and cons here? We'll start with the pros. We have a very high efficiency. It's a moderate net energy at the actual accessible sites. So if you were in the correct geographical location, it can be seen as a very good thing. We have lower carbon dioxide emissions than what we'll see with fossil fuels. It's low cost at favorable sites because you're not having to dig down very deep in order to obtain this heat from the Earth's interior. It's low land use and disturbance and has a moderate environmental impact. Our downsides are going to be that there's a scarcity of suitable sites, so there are only certain places on the planet where we can actually make use of this energy. It can be depleted if used too rapidly. Now, it would generate itself back up in these locations, but it's going to take a while for that to occur. The environmental costs are not included in the market price. Again, there can be carbon dioxide emissions. It's moderate to high local air pollution if your plant is not running absolutely efficiently. There can be noise and odor. It's going to be like that sulfur smell, so like that rotten egg smell. And last, there's a high cost except in the most concentrated and accessible sources like what we see in Iceland.